Hey Venkat, you ready for this? I've made this special explainer just for you, all about Lesson 13. We're going to break down everything you need to know about light, shadows, and reflection, so you'll be absolutely ready for that science exam. Let's get started.
Okay, so here's our game plan for today. Think of this as our roadmap. We'll start with what light is, how it interacts with stuff, get into shadows, reflections, mirrors, and even a cool little pinhole camera. By the end, you're going to be a pro at this.
All right, first up, we're starting with the absolute basics. What even is light? Let's figure out the star of our show. So Venkat, let me ask you something. Have you ever really stopped to think about where light, comes from? Before we get all scientific, just take a look around you right now. Seriously, where's the light in your room coming from? Is it from the window? A lamp?
Well, anything that makes its own light has a special scientific name. It's called a luminous object. Now you're going to want to remember that one, Venkat. That's a perfect exam term. These luminous objects, well, they're our sources of light.
And these light sources, well, they basically fall into two groups. First, you've got your natural sources, things you find in nature, like the sun, the stars, and get this, even fireflies. How cool is that? Then you have the artificial or man-made sources, things like candles, the light bulb in your lamp, or even the laser pointer.
Okay, listen up, because this right here is the biggest, most important rule in this entire lesson. Seriously, if you remember one thing, make it this. Light travels in a straight line. That's it. It doesn't curve, it doesn't zigzag, just a straight line. This one little fact is going to unlock everything else for us.
Okay, so now that we know light travels in a straight line, what happens when it runs into something? I mean, it's got to hit objects, right? Well, how it acts next depends entirely on what kind of object it hits.
Now this chart, Venkat, this is a big one for your exam. So let's walk through it together. First up, you've got transparent materials. Think of clear glass or clean water. Light goes straight through, no problem. You can see perfectly. Next is translucent. This is more like butter paper or that frosted glass you see on some bathroom windows. Light gets through, but only some of it, so everything looks blurry. And finally, we have opaque. Think of a wooden door or a metal spoon. Light can't get through at all. It's completely blocked. Easy, right?
See how that last one, opaque objects, perfectly sets us up for our next section. When an object blocks light, well, what happens? You got it. It makes a shadow. Let's dig into the science of that.
So, how do you make a shadow? It's like a recipe, Venkat, and you need exactly 3 ingredients. 1, you need a source of light, like a flashlight. 2, you need an opaque object to get in the way of that light. And 3, you need a screen or a surface, like a wall, for the shadow to fall on. You need all 3 of those things. If you're missing even one, no shadow.
All right, pop quiz for you, Venkat. Based on that 3-part recipe, why can't you see your shadow in a completely pitch black room? Which one of our ingredients is missing? Think about it for a second.
Did you get it? You're missing ingredient number 1, a source of light. Exactly. Okay, now here are a few more key things to know about shadows. Another great bit of info for your exam. First, shadows are always black. Doesn't matter if the object is red or blue, the shadow is black. Second, a shadow just shows the outline, the shape of the object. And third, its size can change. Move the light closer, the shadow gets bigger. Move it away, it gets smaller.
All right, next big idea. We know opaque objects block light to make shadows. But what about all the things we see around us that aren't light sources? How can you see your chair or your textbook? They're not glowing, right? The answer is reflection. Light is bouncing off them. But here's the thing, not all reflection is the same. When light hits a rough surface, like a piece of paper, it scatters and bounces off in a million different directions. That's called diffuse reflection. But when light hits a really smooth surface, like a calm lake or a mirror, it bounces off in one single, neat direction. And that is called regular reflection. It's that regular reflection that lets us see a clear image. And that idea of regular reflection brings us right to something you probably use every day, a mirror. Let's talk about that person looking back at you.
Okay, here's a fun little brain teaser for you, Venkat. I bet you've noticed this before. When you stand in front of a mirror and you raise your right hand, the person in the mirror raises their left hand. So weird, right? What's happening there?
Well, science has a really cool name for this. It's called lateral inversion. Lateral just means side to side, and inversion means flipped. So it's literally a side-to-side flip. The mirror reverses your image left to right. That is a super important property of mirrors to remember.
All right, we're on our last topic now, and this one is really cool because it's a simple little camera that actually proves that big rule we learned at the beginning. Let's check out the pinhole camera.
So how does this thing work? It's basically just a box with a teeny tiny little hole in it. And here's where our big rule comes back. Light travels in straight lines. So the light rays from the top of an object go straight through the hole and hit the bottom of the back of the box. And the rays from the bottom of the object go straight through and hit the top. They cross over. And that's why the image you see inside is always upside down or inverted. And get ready for this, because this is an amazing fun fact. Your own eye works almost exactly like a pinhole camera. Light comes in through your pupil, that's the pinhole, and it actually forms an upside-down image on the back of your eye, on your retina. So why don't we see the world upside down? Because your amazing brain flips the image right side up for you instantly. How incredible is that?
And there you have it. Great work today, Venkat. You totally nailed this. We've gone through what light is, what happens when it gets blocked and makes a shadow, and how it bounces back to create reflections in mirrors. You've mastered the whole lesson.
So, if someone asks you for the one key takeaway from all of this, here it is. Light travels in straight lines, and pretty much everything else, clear images, dark shadows, how mirrors work, it all comes from how that straight traveling light interacts with different objects. That's the whole story.
Seriously, keep up the great work, Venkat. Keep studying, and I know you are going to do wonderfully on your exam. You've totally got this. And hey, if this helped you out, make sure to share it with your friends. That way you can all understand it better and ace your test together. All the best!